Hello there, so today we are going to talk about gas chromatography. So what actually on earth is gas chromatography? Simply put, it's actually a chromatographic technique that uses gas as the mobile phase, which are also known as the carrier gas, and also solid or liquid that is used as the stationary phase. Interested? Then keep watching. This is a basic process flow diagram on a gas chromatograph, where we can see the mobile phase is flowed continuously as the sample is injected into the injection port. The mobile phase is an inert gas, where typical examples of them are helium gas and nitrogen gas. The injection is done by using a microsyringe that can measure up to 1 microliters. The injection can be a split or splitless injection depending on the circumstances. In split injection, only a small proportion of the sample is sent to the column while the rest are purged. This is usually done on samples with small number of components, and this method saves a lot of time. In splitless injection, the entire sample injected is fed to the column, where this method is suitable for trace analysis.
The mobile phase then carries the sample to the column. The column is the heart of the gas chromatography system, where the separation of the sample occurs.
There are generally two types of column, the open tubular column and the packed column. Open tubular column is used for high efficiency and sensitivity, but comes with a high price, whereas packed column is favored for ease of operation and low cost. The column separates the sample and elutes them according to certain properties of the sample, such as polarity. The detector then picks up signals from the eluted substance and sends the signals to a microprocessor or a computer with specialized software, where the retention times and signal peaks of each substance is plotted in a chromatogram.
In this video, we are going to make a few assumptions and bases in order to explain gas chromatography step by step in a simple manner. Firstly, the analyte that we are going to detect are all alkanes from C6 to C14. Secondly, a flame ionization detector, also known as FID, is going to be used to detect all the analytes. Next, the column that is going to be used is a non-polar porous layer open tubular column, also known as PLOT, model name Ultra 1, that elutes polar substances first, followed by non-polar substances. Then, the oven is programmed to heat up from 40 degrees to 150 degrees at a ramp rate of 5 degrees per minute. This programmed temperature heating procedure is done to speed up the elution process, thus saving time. Finally, we also assume that this setup is for qualitative analysis only, which is to only determine the type of analytes present in the sample.
To carry out gas chromatography, we must firstly prepare the standard of analytes in order to obtain the standard retention times. Alkanes from C6 and C14 are mixed together and a suitable solvent, typically dichloromethane, is added. The solvent used must be more polar than C6 and therefore will be eluted first. The solution is then injected into the injection port and the retention times of each component is recorded. The first retention time should be the solvent, and the second one is C6, and so on until the last retention time is C14.
Before we can inject the sample into the injection port, we have to prepare the sample first. The sample should be liquidized in order to measure the volume and also concentration.
If we have a large number of analytes to be used, we should first dilute it with a stable solvent. The solvent used is usually a substance that has the highest polarity. The sample is then injected to the port and retention time are recorded. The retention time for both standard and sample are compared, and some of very similar retention time are hypothesized to be the same analyte. In order to confirm the hypothesis, we must run the gas chromatography again with a sample bite with the standard.
There are few advantages of using gas chromatography over other methods. Gas chromatography is time-saving method compared to others. A sample takes around 30 minutes to be completely analyzed in in gas chromatography, whereas in other methods such as gravimetric analysis, it takes at least around 1 hour to be completely analyzed. Apart from being easily operated and automated, gas chromatography can analyze multiple analytes at a single run. Gas chromatography is also very accurate, sensitive and precise.
And that concludes our brief and concise explanation on gas chromatography. We hope you had a great time watching our video. See you next time.